Okay, friends, today's lesson on 3.1, Introduction to Matrices. So first of all, let's deal with that fact that it's asking us for the order. Order is just another word for dimensions. So when we go to fill out the order, all we're going to do is we are going to say that there is 1, 2, 3 rows and 1, 2 columns. So the dimensions of this matrix are 3 by 2, or the order of this matrix is 3 by 2. So we're going to name rows first, and then we're going to name columns second. And so then when it asks for the elements, so for instance, when this right here asks you for the elements, it is actually asking you to find the first row and the first column number. And the first row, first column number is 6. And then it's asking you for the second row, first column number. And the second row, first column number is -2. And then it's asking you for the third row, first column, and the third row, first column is 0. And then it's asking you to find the first row, second column, and the first row, second column is 8. And the second row, second column, the number is 0. And the third row, second column is 5. So again, we have row 1, row 2, row 3, and we have column 1, columns. Okay, my friend, that's simply how to name them by, or how to identify their order and their elements. Okay, so then let's do this one. So if we look at this, we are going to notice in the first matrix, first row, first column is the element x minus 4. In the second matrix, and what it is equal to, first column, first row is 0. So that must mean then that x minus 4 is equal to 0. So then x is equal to 4. And then you will notice that we have second row, first column is 2y plus 1. Second row, first column is 1. So they're equal to each other. So they're correspondence, if you will. They correspond. And we have the equation 2y plus 1 is equal to 1. So 2y is equal to 0. So y is equal to 0. And then we have first row, second column, first row, second column. So we must have the equation that 5 is going to equal 3z minus 1. So 6 is going to equal 3z. So 2 is going to equal z. And then we have second row, second column, second row, second column. And so we have, they're both in the same element. So we have 8 is equal to 3w minus 7. So 15 is equal to 3w. So 5 is equal to 1. And so that is how we solve a matrix. Next, we are going to add. First, we have to make sure they can be added. And they can be added because this has 2 rows and 3 columns. And this one has 2 rows and 3 columns. So as long as those are the same, as long as these are the same, in other words, as long as the matrices are the same size, then they can be added together. And so all we're going to do is add them together. So very simply, we are just straight up going to add. Don't make this harder than it is, because it is not. It is not hard at all. All you're going to do is take this 4, and you are going to add it to 5, and 4 plus 5 is 9. And then you're going to take 10, and you're going to add it to 2, and 10 plus 2 is 12. And then you're going to take negative 1 and add it to 8. And negative 1 plus 8 is 7. And then you're going to take negative 15. And negative 15 plus 4 is negative 11. Got the idea here by now, friends. 9 being added to negative 19 is going to give us negative 10. And last but not least, 5 being added to 5 is 10. And then we put the little matrix marks on it so we know it is a matrix. And so in Canvas, it's going to say, Canvas is going to say, what is the resulting vector of the first element, first column, first row, and you're going to say that is 9. And then it is going to say, okay, what is the result in the second row, first column? And you're going to say 12. And then it is going to say, okay, what about the result of the first row, second column? And you're going to say 7. And it's going to say, what is the result of the second row, second column? And you're going to say negative 11. And then it's going to say, what is the result of the first row, third column? And you're going to say negative 10. And then it's going to say, what is the result of the second row, third column? And you're going to say 10. And so that's what you're going to plug into Canvas. In Canvas, you are going to put, I think in Canvas, we just have a box here, and a box here. And so all you do is fill in those boxes, friends. I didn't want to make that one a box. I must have been too wonky. So all you're going to do is fill those in. So you can only add or subtract matrices if they have the same dimensions. So if we go up here, so we can only subtract if we have the same dimensions. And so you'll notice that we have, both of them have 2 rows, and both of them have 2 columns. So because the dimensions are in fact the same dimensions, they can indeed be subtracted. And then you're just going to do that subtraction. So you are literally going to do that subtraction. I need this. So you are going to take, and you're going to take 0 minus negative 7. And 0 minus negative 7 is 7. And then you're going to take negative 9. And you're going to take negative 9 minus 4. And negative 9 minus 4 is negative 5. And you are going to take 1 minus 2. And 1 minus 2 is negative 1. And you are going to take 4 minus negative 15. And 4 minus negative 15 is 11. And then you're going to put the matrix marks on it. And there you go. There you have it. That's all there is to it. And so we have 3 matrices here. But all it's asking us to do is to take, all it is asking us to do is to take 4 times A. So this is called scalar multiplication. And all we're going to do is take this entire thing. All we're going to do is take this entire thing and multiply it by 4. So we're going to take 4 times every element. So 4 times 0 is 0. 4 times negative 8 is negative 32. 4 times 1 is 4. Then we're going to take 4 times 5 times 8 and times 1. 4 times 5 is 20. 4 times 8 is 32. And 4 times 1 is 4. And then we're going to take 4 times that times that times that. And 4 times negative 3 is negative 12. And 4 times negative 4 is negative 16. And 4 times negative 5 is negative 20. And that is all there is to it, my friends. Okay? And so then it's going to ask you for the resulting vector. So it's going to say, what is the resulting vector of row 1, column 1? And you're going to say 0. And it's going to say, what is the resulting vector of row 2, column 1? And you're going to say 20. And it's going to say, what is the resulting vector of row 3, column 1? And you're going to say negative 12, etc. Okay? All right. So that's what we did there. Let me erase all those. Those are horrible. So then for the next one, it says negative 3b. So we're going to take this entire thing, and we're going to multiply it by negative 3. So we are going to take negative 3 times every element. So we're going to take negative 3, and we're going to multiply it by every element. So this would be negative 3 times 4 is negative 12. Negative 3 times 5 is negative 15. Negative 3 times negative 9 is 27. And negative 3 times 0 is still 0. And then we're going to put it in the matrix box. So it looks like a matrix. And then it's going to say 4 times b minus c. So 4 times b minus c. So let's grab b. 4 times b minus c. 4 times b minus c. So copy. So we are going to take 4 times b. So we're going to take 4 times this. And then we are going to subtract c. And what is c? This is c. And then we are going to subtract that. So really what we're going to have is 4 times b would be 16. Well, let's go with a different color. Let's go with pink. Let's go with 16, 20, negative 36, 0. And then we're going to subtract this. So 16 take away 9 is 7. 20 take away 7 is 13. Negative 36 take away negative 8 is negative 44. And negative, or 0 take away 7 is negative 7. And so there we go. So we would say that our result of first column, first row is 7. And our result of second column, first row is negative 44. And our result of first row, second column is 13. And our result of second row, second column is negative 7. And that is it, my friends. That is the basics of matrices. That's the introduction. So there you go. Thank you.